I'd like to talk about update fraud detection, the journey to make e-commerce more secure. I am the Commerce CTO of Commerce Group, Commerce Infrastructure Division of Yahoo Japan. My name is Daigo. This is today's agenda. First, I'd like to talk about the need for fraud detection of e-commerce. And then I'd like to talk about the Yahoo's fraud detection system. Now let me start with the need for fraud detection. Our daily lives are being digitized. Those people who have computers and smartphones never spend a day without looking at or touching these devices. For example, collecting information through news site or getting in contact with people through social network. Without knowing, we have moved to the digital world. So buying something, that experience is being digitized as well. When you buy something, what do you use? When I buy something, I mainly use credit card. I almost never use cash. The cash is interesting. There are bills and coins made of paper and metal, and they do not have any values themselves. But they are valuable so that you can exchange the money with goods of some value. So it's very simple with cash. So why can you buy things with credit card? Credit card itself is not valuable. You cannot exchange card with goods. At the physical stores, when you buy something with credit card, some kind of terminal is necessary to read the card. So I'm not talking about the mechanism of making payments with a credit card, but some data are tied to the data so that you can purchase things. So buying something has shifted from using cash to using data. Now, human beings are doing the shopping using data. So as buying something with data become common, e-commerce developed. Over the internet, you can buy and sell goods. I often use it at home and outside, and from anywhere you can place an order and you can get the delivery, so it's very convenient. I'm sure that you have at least used once. So let's think about when you use the e-commerce service. When you buy something using the e-commerce service, what did you do? I'm sure that you have put whatever you want to buy into the cart. But we'd like to focus on placing an order. So entering the credit card number and enter the security card and press the order button. So this is all the matter of course. But what I'm trying to say is that when you use the credit card using the e-commerce, the card doesn't have to be there. You don't have to have a card with you. In the case of e-commerce, if you have the card information, you can make purchases. As I said, our daily lives are being digitized. And there's another thing which is being digitized. That is fraud. Once again, let's think about how you place an order using the e-commerce. You entered card number and security code. So if this was a phishing site, you would have given the card information to the fraudsters. So let's look at it from the fraudsters' point of view. How do you take advantage of the information that you have stolen? Credit card itself is not valuable, so you want to get something valuable using that information. So method is simple. When you steal a card information, you would purchase something with that information and sell that. So you can get cash with this.
ではこれはどこで起きているんでしょうか?
Where is the fraud occurring? The fraudster only has information of the card and they want to buy something and sell that. You That would be the e-commerce market. This is the amount of damage that was reported by the Japan Consumer Credit Association. The horizontal axis tells you the year, and the vertical axis is the amount of damage from the fraudulent use. The non-face-to-face transaction has generated about 31.1 billion yen of fraud or damage. From January to June of 2022, 19.5 billion yen was the damage from the fraud, which is over 50% of 2021. Why is countermeasures against fraud necessary in e-commerce? Because digitalization of life has advanced, and more digitalization of fraud has also progressed. And for the malfeasant or the fraudsters, this e-commerce is a perfect patsy. Let me talk now about the fraud detection system in Yahoo Japan. I gave some examples of fraud of credit cards, but it is not limited to the credit cards. This is the fraud countermeasure community group of W3C. The types of fraud is being listed here. To give an example, they're very diverse. Credit card fraud, or taking over accounts, or a violation of the terms of service. Also, the MOs of fraud is constantly changing. The reason is, if the fraudster is making daily income from fraud, they don't stop once they are stopped. If their one MO doesn't work, they will try to circumvent that. So, since fraud is becoming more and more diverse, Yahoo Japan has developed its own fraud countermeasure system. This is a highly versatile framework. And there is a team that conducts screening. There is a team that analyzes the data, manages the data, and also a team that does function development. We work together in order to update countermeasures against fraud. Specifically, how do we work together and update the mechanism? This is the feedback loop. First, we have the rule to decide or to determine the fraud detection, and then going clockwise, we have a real-time automatic determination of the fraud. There is also an expert team that also does the screening visibly, and then that is being aggregated in the database internally. We conduct reporting from the data so that we can update the rules as needed. How did this fraud detection system, how was it formulated, and how has it been improved? Going back to 2014, fraudulent access was already in existence. There was a mechanism to block IPs, but there was no logic for fraud countermeasure per service. It had to be the actual essential business logic wasn't exactly there. The more the fraud became complicated, the cost became more expensive, and the forecasting became expensive. So the first generation fraud detection system was born at that time. This is a client-server type deny listing system. So the embedded logic per service or statistical or machine learning mechanism was implemented. Also, we were able to have a special task be embedded in the machine learning model. So this was the first step of Yahoo Japan's fraud detection system. We spent about 5 years operating and updating this system. Some of the improvements made by this system is that the separation of the service implementation and the fraud countermeasure logic, where the separation became possible. Also, the logic tuning became possible per service, and the 2 millisecond per transaction detection became possible for screening. However, there were challenges. The code could be separated from the service, but the fraud detection logic was still hard-coded. Also, the machine learning models updating cost was expensive, and the related subsystems, the various notification methods varied, and the screening members had to go look at different places. So in order to resolve these issues, a rule-based judgment web API was introduced to do a settlement transaction, which was a major structural change. So the database that stores the rules has the feedback loop. So you can actually register the rules in the dedicated web tools so that you can do a real-time screening of fraud detection. Cassandra is used in the database to save the rules, so that the semi-structural data is used for the rules for very speedy data exchange. The structure of the rule is being supplemented, and it is a logic operations that has been combined with multiple and/or conditions. Based on this structure, multiple conditions can be set for the rules, making it more flexible. The structural transformation of web API has made the installment to the client library unnecessary, and also the changes to the logic on the service side has become possible immediately. Also, whatever that was screened on the subsystem was aggregated into one logic, so that the screening member's burden has been reduced. However, the rules were managed manually. That was the challenge. The rule-based screening managed by a human being makes it very complicated because it's done manually. And as the rules become more sophisticated, the management of the rules become tacit. And to combine large number of parameters to detect the fraud becomes very complicated. So I think it's important to get rid of that type of complication in order to improve the system. So the combination of machine learning and rules, the fusion of the two, and also the data-driven rule operation became the solution. The first axis is about the machine learning and the rule fusion. So let me summarize first. In fraud detection, it's important to detect the transaction as being fraud, but it means that you must not detect a normal transaction as fraud. If you stop a normal transaction as being fraudulent, then you cannot do a proper purchase. Also, when you do a fraud screening or judgment, there's a very high accountability. What do you judge to be fraud? If that becomes a black box, even if it was really fraudulent, you cannot stop it, and you would lose the grounds to stop it. In other words, in order to introduce machine learning into fraud detection, you have to try to refrain from false positive judgment.
So based on this assumption, we incorporated machine learning based on three aspects. One is automatic rule management, rule generation and management. And second is inference as parameters. And the third is automatic model update. So I'd like to introduce each one of them. First is automatic rule management. Using the past fraudulent data stored in data warehouse, using the machine learning, automatically we can generate and manage the rules. The algorithm used the decision tree. So we generate the decision tree model based on the past fraudulent data and select the nodes with low Gini diversity index. And extracting the forked information to the nodes, we will try to convert that to the rule. So we make sure there is a high matching and explainability. And we can automatically update the rules based on the past data. So we can reduce the cost of manually managing the complex rules. Instead of using the decision tree model as is, it is merged with the rule-based system. That is the key. So within the existing framework, we can take advantage of the machine learning. Next is the inference as parameters. Using the model trained with the past fraudulent data, in a similar way as the automatic updating, here we use the gradient boosting decision tree so that we can use the inference score as parameter. With this function, the vis-a-vis the arbitrary rule managed by the human beings, we can embed the machine learning inference. So instead of using the model output as is, it is a rule-based system, and the key is the rule-based. So at which score do we detect? We can adjust that freely. And also you can combine this with other conditions to set the rules. The rules themselves can be updated easily. So the real-time change of the decisions or the results can be done based on the model score. In order to realize this function, we set up the inference API specifically for the fraud detection. So we did the model inference on the Java application, and the gradient boosting decision tree library Yandex Cat Boost is utilized so that we have clarified the condition that the Python model development is conducted. And this inference API is loosely coupled with the fraud detection system as a whole. So if the parameter is changed, or if we have more models of the inference API, we will not be influenced. And inference API itself also has a loosely coupled interface with the content of the model. So you can change the file, configuration file, and build it to the model, and also eliminate it. But since the gradient boosting decision tree is used, the user input and text-based parameter is difficult to be used for the inference. So using the user input text as a scoring model, this is built with the TensorFlow. And with this, the human tacit knowledge can be quantified, and you can replace the work, for example, listing up all the text within the rule manually. Use of the TensorFlow model, you cannot accommodate the inference API developed by ourselves. So we use the Carisarc, which is the model serving platform, so that we can realize the high-speed inference using TensorFlow serving. The third is automatic model update to follow changes of the fraud pattern. The fraud patterns are changing. So when you use the model for some time, model inference without the new knowledge about the new fraud would not be realistic, and it would deteriorate. So sometimes there is a changes of the popularity of the products, but also the model inference itself is utilized for the rules. So from the fraudster's point of view, this could be the way to avoid the model. So we need to update this automatically so we can follow up the pattern of the fraud. So I talked about automatic rule management and inference as parameters and automatic model update. So with this, from the machine learning perspective, we have updated the fraud detection system. Second is data-driven rules. Now, the data analysis and utilization, updating them is important in continuously conduct the fraud detection. As for the rule operation of the human beings, there are challenges. So the manual work is very cumbersome. So machine learning can be combined, and we can try to solve this challenge. There are two remaining ones which are not yet solved. As the rule becomes more sophisticated, the more tacit knowledge the individual derives. So you will need a skill to know what needs to be set up, and also you have to know other information about the past fraudulent information, so that it would be difficult to try to follow the latest pattern of the fraud. And the human beings need to combine different parameters, then there is a limitation for that. So if there are several of them, it's manageable, but actually the number of the parameter is huge. So concerning those remaining challenges, we try to make some improvements. I'd like to give you some update. First of all, the fraudulent keywords ranking. The next is the deny listing of the network analysis and the company-wide database. Let me talk about the fraudulent keywords ranking. As you can guess from the name, we will calculate the ranking of the frequency of the products or the keywords that were attacked by the fraudsters. So the members who are doing the rule management will look into what were attacked and whether the product has already passed the peak based on the commonality. So, for example, the trend that you might have had in your head can be quantified so that you can work on the rule management of the fraud detection with the foundation. So next, I would like to talk about the deny listing using the network analysis.
So when you conduct the analysis of the fraud settlement, then you can create a deny list that is associated with several fraud settlement, and you can update that. So you can automatically block whatever that is tied to the concerned items of concern. So instead of manually updating the deny list, this is being done by the function. Next is the company-wide database. So at Yahoo Japan, we have an anonymized user database that is being used company-wide. Also, the fraudulent information is shared by the database platform by the company. So the parameters in other services can also be discerned. So these two are described as company-wide database. Before we were able to link the database, we had to look at each one of the transactions of the service in order to set the rules. But in a different service, when the parameters were used fraudulently, you had to obtain the data yourself manually in order to set the rules. Also, within the transaction, only parameters in that transaction were being used for the screening. Therefore, you didn't know if that user had conducted a fraudulent activity in the past. But by using this company-wide database, whatever user accounts settlement that was fraudulent in the past can be obtained as an information. Also, suspicious actions or movements can also be detected. So it is not a post-analysis, but analysis on a real-time basis to detect fraud. So deny lists of people who seem suspicious do not need to be obtained by the programmers. So the rule-based fraud detection system is a challenge because it is based on the human being. The tacit knowledge is one such issue, and also very sophisticated rule management and complicated parameter analysis has been a problem in the past. But with this updating system, we can get rid of all these complications. The data-driven rule operation and machine-learned fraud detection is what I have explained so far. So these are indispensable as we try to introduce countermeasures against fraud. No matter how wonderful the system is, if the rules are difficult to manage, the countermeasures become delayed. And even if the rules are easy to manage, if the system can't do too many things, it will become very inflexible and it will become incompetent. The system, people, both need to be updated. One more point as a point of improvement. I would like to introduce a new attempt. The fraud detection systems that I introduced in the past were mostly for settlement transaction, in other words, single settlement attempts. But the fraud detection system has added a lot of functions, but there are a lot of overlooks. The fraudster, once their particular MO is stopped, they will try another MO, and in addition, whatever that may seem like a single once fraud may not be such a case. So in order not to allow this overlook, you need a multiple settlement transaction countermeasure. And this is something that was done by visual inspection in the past. In order to make this into a system, we introduced a patrol type detection. More specifically, the screening log was used so that this type of detection can be done for multiple transactions. So the patrol is done automatically, and in a short-term basis, using the log, non-real-time fraud detection is being implemented. So multiple transactions can be detected for fraud. Yahoo Japan's fraud detection system has made one step forward. Let me summarize. So Yahoo Japan is trying to realize a much more secure e-commerce, and we are updating in order to implement a much more sophisticated fraud detection. So the credit card fraud use has been very successful, and I want to introduce one example. Yahoo Japan Shopping and PayPay Mall is one of the shopping business. I will not be showing any specific amount, but the vertical axis is the amount of money, and the horizontal, the blue, is the amount, and gray is the prevented amount. So as more and more sales grew, the amount of fraud also grew. But in 2019, the fraud detection system that was rebuilt has been able to keep flat the amount of damage. Next, this is the reuse business, which is Yahoo Auction and PayPay Flea Market. The graph is similar. It shows how much fraud was prevented and the amount of fraud that was attempted. In 2019, the fraud was at its peak, but with the introduction of the detection system in 2019 and 2021, if you compare the two, fraud was reduced by 60%. The improvement was much better than the shopping business. So Yahoo Japan is trying to make e-commerce more secure, and we will not stop. Well, Yahoo Japan is aiming to make e-commerce much more secure and to also stop fraud. That is all. Thank you very much.
Thank you very much, Mr. Daigo. So let's start the plus talk. We will focus on some of the things that the questioner are interested in. We will also take questions from the audience as much as possible. If you have any questions, please use the question mark function to post your question. The questioner is Akihiro Ishida of LINE. Hello. Mr. Ishida, would you introduce yourself? Yes. Plus and safety team, I belong to that group. My name is Ishida. So account takeover and the spam, some of the frauds happening in line is what I am responsible for. Thank you very much. So Mr. Ishida, after listening to the presentation, anything that you want to know further? Yes. Thank you very much for your presentation. I think that the method of fraud is changing. So how to update the countermeasure was discussed, and it was extremely interesting. First question that I have is as follows. You talked about three factors to operate the machine learning, and one was the automatic rule generation, and also using the machine learning for the rules, and also the automatic update of the models. Those three were mentioned. So among those, the first one, the automatic generation of the rules, why did you start doing this? Yes, thank you. But the automatic rule generation, the rule-based fraud detection is what we have. So all the rules managed by the human being is possible, but the trend of the fraud is changing all the time. So setting the rules by the human being, when the rule stops, that rule no longer can be utilized. And also, without a human being noticing, the fraud could accumulate, and the people could probably forget to set the rules. So something that is missing among the human being exists. So I wanted to complement that with automatic method. So as much as you can discuss, how many rules do you manage? Well, I cannot mention a specific number, but hundreds of rules, actually hundreds of rules, I see. But the granularity is different, so it's difficult to say. I see. I understand. So hundreds of rules. Yes, automatic generation could be the motivation. Yes, if it's several, of course, that the person can remember them and making judgment that this fraud is no longer happening, for example. So as long as you remember, if you have more than 10, it's difficult to manage. So you want to complement or supplement the human beings with the automation. Outline, you talked about three things: the rules and parameters, and using the machine learn, and updating the models automatically. That's something that we do for the fraud detection. But the rule automatic generation, I haven't seen that much. Also, other companies, I haven't really heard other companies doing it, and I was interested in that. So if there are hundreds, it is possible that unless you do automate it, it's difficult to manage. So I understand. So at line, whether it is possible or not, that's something that I'd like to consider.
The second question. In your presentation, Mr. Daigo, you mentioned the accountability has to be guaranteed. False positive also needs to be reduced. I think in fraud detection, this is an important concept or approach. So these false positives, what are the types of frauds that this might occur very frequently? So what are the MOs, that is to say, where you have these false positives? Sometimes you may have to let the human being do the checking. If there is such a case, would you like to tell us? Okay, the premise is, if it's a very clear fraud, and if that's the kind of settlement that is normally determined as fraud, then we would block that. But everything else, it goes to the screening team. it is escalated to the screening team, so the human being will make that judgment. So false positives. Well, I think it has to do with security. I don't know how I can disclose. Are you still there? Are you frozen? It seems your screen is frozen. No, I'm fine. Well, false positives, false detection, whatever that was running normally and never had any problem can be a false positive. So when you purchase something and someone else pays for you, that's becoming more popular now. So the user was doing a normal purchase up until that time, but from that point on, maybe it becomes a fraud. I do understand your point of view. This is an issue that's very difficult to introduce a countermeasure. Even with human eyes, sometimes it's very difficult to detect the fraud. So yes, it can be a false positive. As much as you can disclose, what is the percentage of transactions that are sent to the human being? If you have like specific percentage, well, as percentage, well, we don't have percentage numbers, but well, I cannot give you specific numbers. I don't think I can answer that question. Okay, that's fine. But okay, so if there's there is very few rules where the blocking happens immediately. Normally, it escalates to screening. I see, but you may think that we are screening everything, but this fraud detection system, this can also detect correct transaction based on the rules, right? So if this is the kind of settlement, if it's a transaction with this kind of settlement, it is normally considered to be a proper transaction. So it doesn't mean that all transactions are escalated to screening. I see. So whatever that's considered to be proper transaction is not sent to fraud detection. Now, you mentioned about feedback loop.
So, well, again, it talks about the false positive, but how do you make a judgment? And for the rule improvements, do you actually utilize the inquiry information from the users? Yes. When there are user inquiries, say that the normal user were considered to be fraudulent, or it was a fraud, but the fraudster says that they're not the frauds. Yes, that happens. So something like that, through the evaluation team or screening team, we collect that information. So weekly, we have updates. So in the weekly meeting, we talk about that, and we share what is happening. So the voice of the customers are reflected to make improvements. So feedback comes into the data warehouse and analyzed and improved. I think there was a flow. So data warehouse, it does not come into the data warehouse, or is it separate? Well, data warehouse itself, the inquiries from the customers do not go into the data warehouse, no. So the inquiries from the customers, the communication with the customers, so the employees are building the fraud system, you cannot show that information to us, so it's separated. So in that sense, it is not stored in the same place. So the information about the inquiry to understand the false positive, I think, is important. So with that, sometimes you find out that it was a false positive. So I'm wondering whether this can be utilized for the rule improvements. So when the users make an inquiry, of course, before doing that, there is a time lag. And maybe it's only with our system, but the engineers do not check that information directly. So there is a delay there. And at the same time, the content of the inquiries, general users do not know the details of the system of the services. So the content of the inquiry is vague or sometimes wrong. So how can we label them and fed back to the rule improvements, and if possible, automatically? And I myself am struggling with it. So the inquiry information from the users, seamlessly utilizing for the improvements. Is there something that you are doing at the Yahoo Japan? Well, from that perspective, not really. Automatically and seamlessly linking it is not yet done. But sometimes the false positive, it was not a fraud, so data is updated. So as a result, the model to train the data and automatically generated data, so the wrong judgment or as a correct judgment is once again created in the system. I see. So you have a system that you can reflect such feedback. I see.
Thank you very much. Those are the only questions that I had. Thank you.